Hi there, welcome to this C tutorial from in 28 minutes. In this video, we will learn about pointers. We will start with the basics of pointers. We will understand what is a pointer looking at hands-on examples with code and a lot of pictures. And then we would move on to understanding advanced concepts with pointers, including arrays, structures, and a lot of other complex things. Let's get started now. Most of the code examples that we would be using are on GitHub in the repository C tutorial for beginners. Look it up and you would see a lot of programs in here which would help you to get started.
In this section 5 on pointers, we will learn the basics about pointers. In this video, let's look at the different things related to pointers. What is a pointer? What is the address of operator? What is star operator in relation to a pointer? We use star in a number of contexts. And how do you pass a pointer to a function, and how do you declare a function to receive a pointer? So this and a lot of other questions we would discuss during this video on pointers. Let's start off. I'm having a simple integer variable with a value 1. So what is a pointer related to this particular thing? Let's go to the background. When I said I is equal to 1, the way it would happen is I is pointing to a memory location. Somewhere the value 1 is stored. So the value of I is 1. This is stored in a particular memory location, 6000. For example, it could be anything. I'm assuming this is 6000. So the memory location of I, the place where the value of I is stored is 6000. What is the value? 1. If I change I is equal to 5, what happens is this value 1 here would be changed to 5. So that's basically how variables work, right? I make a change in the value. The appropriate change is done in the memory for that particular value. That's normal. So what is a pointer? A pointer is something which stores not a value. 6 here is a value. I stores a value integer. So what kind of value does the I store? I stores a integer value. So I stores an integer value of 6. In this pointer, I don't want to store an integer value. What I want to store is where I is storing its value. What is the memory location of I? I would want to store it in a variable. So what I want to store here is 6000. That's where I is being stored. I don't want to store an integer, but I would want to store the address location of this particular variable. So I would want to store the address of I. Address of I is 6000. This 6000 I would want to store in a variable, and then that variable is called a pointer. A pointer is nothing but a reference to another memory location where a particular value is stored. Pointers can be multiple levels. Then it's pointed to a memory location where a memory location is stored of another value. That's a two-direction pointer. It can be at multiple indirections, but at the basic level, a pointer stores the memory location of another variable. So here the variable is I. I is a normal integer variable, and the pointer stores where I is stored. The address location of I is stored in this particular thing. So how do I declare a pointer? First thing is, the way you declare a pointer is by saying usual thing in pointer. So this would make pointer a integer. Pointer is an integer. Pointer is not an integer. Pointer is pointer to an integer. So pointer stores the address of an integer. How do I say that? Is by putting a star before it. So this declares a pointer. So now pointer is a now you have declared a pointer, and now pointer can store the address of I. I don't want to store I. I don't want to store I. I want to store address of I. What is the operator for address of operator in C? What is the address of operator in C? That's the ampersand. So now I am storing pointer is equal to address of I. So let's go through the sequence of steps. Int I is equal to 1. Int I is equal to 1. A value 1 is present in 6001. Int star pointer. So a pointer is created 7000. It still contains garbage because nothing is initialized to it. I is equal to 6. And pointer is equal to address of I. What is the address of I? Address of I is 6000. So now at pointer the value becomes 6000. So that's good. So now I know the address of I. So I would want to access what is the value present in that pointer. So pointer contains 6000. What does the memory location 6000 contains? It contains 6. I would want to print that value. So I would want to find the value at the pointer. I would want to find this. How do I do that? We use the value at operator, which is star pointer. So let's printf that. So let's printf %d comma star pointer and print this out. And let's see what would be the output. You would see that the output is 6. The way it would work is the value at operator takes the 6000. So I would want to find the value at this pointer. So the pointer is pointing to 6000, and what does it contain? It contains 6. So that's the value at operator. I can also print the value of the pointer itself, which memory location it's pointing to. And let's see what it prints. It prints some memory location. So this is not really 6000, but this is something like this. And so this is also something of this kind. So another memory location somewhere in the thing. So this memory location contains this value. The pointer points to this memory location. And when I do a star, this goes to the memory location, fetches the value, and returns it back. That's how a pointer works. That's quite simple, isn't it? So we saw what is a pointer, what is the address operator used for, what is the star operator used for. Star is used while declaring a pointer as well as when you want to find the value at a particular pointer. So star is actually doing dual purpose. It indicates that a variable is a pointer, and also you can use it to dereference a variable and find the value at a particular address. So those are the different things related to a pointer. Now, in this video, let's discuss about a few questions related to arrays, how they are stored in memory, how are arrays and pointers related, and also can we change the address pointed to by an array, and what are character pointers, and what is the difference between a character array and a character pointer. So those are the different things that we would want to touch upon while discussing a lot of other things during this particular video. Let's get started. How are arrays stored in? We are declaring a array int numbers is equal to 1, 2, 3, 5. How is this stored in memory? In this particular example, we are assuming the size of an integer is 2 bytes. In some compilers, it might be larger. Let's assume it's 2 bytes. So the memory locations, let's assume that the array is stored at a memory location 6000. So it might be not be 6000, it might be 100,000, 200,000, or some hexadecimal number, because that's how memory locations are referred to by. I'm just making it simple and assuming it's 6000. I'm not using hex numbers here just to make it very simple for us to understand. So the array has 5 values. This is how those 5 values would be stored. The 5 values would be stored in consecutive locations 1, 2, 3, 4, and 5. If the first element is stored at x, then the second element would be stored at x plus 2, if 2 is the size of integer, x plus 4, x plus 6, and x plus 8. And numbers, which is the name of the array, would be pointing to the first location of this particular array. So numbers would be pointing to the first location of this particular array. And this is how the values of an array be stored in memory. The next thing is, how are arrays and pointers related? The thing about arrays is, in C, the name of the array is actually a pointer, but it's a constant pointer. What do we mean by that? Let's get started. So how do we declare a pointer? We learned it earlier. So the way we declare a pointer is by int I would be an integer. If I want to make it a pointer, I would make it int star I. I would be little better, so I'll call it int star pointer. And you'd see that I can store in this particular value the name of the array. So what happens is, this pointer becomes, the value of this pointer is the value of the first element in this particular array. Numbers points to 6000. So pointer would also contain the same thing, 6000. So pointer would contain 6000, which is where the first element of this particular array is stored. So if I print the value now, printf %p is used to print pointers, %p, I would want to print numbers, which is the array reference, and the pointer variable. And let's see what the output is. Compilation. Let's print this and see what happens. So you'd see that both of them print the same memory location, 0x1. Oh my god, this is quite a simple memory location to remember. So now, if array is nothing but a pointer, can I change it to point to somewhere else? Can I say int j is equal to 5, and can I make numbers point to the address of j? Numbers is equal to address of j. J is a variable, address of j is a pointer, so can I put that value in a numbers? Nope, not allowed, because numbers is a constant pointer. So I cannot store. So there's a small mistake in this video until now. The open bracket, close bracket for the numbers was missing. I have added it in now. Actually, in the entire video, it should have been there, open bracket, close bracket, to say that numbers is an array. It's not a problem, I guess. It was working as it is, but when I started doing the constant pointer thing, it started failing. So I've added that in now, and if I'm doing numbers is equal to address of j, it doesn't work because numbers is a constant. So numbers is a constant. You cannot change numbers to point to somewhere else. That's number one. Now, if number is nothing but a pointer, can I print the value at that pointer? Can I print the value at this particular numbers? Numbers has value 1. Let's see if I can print the value at that number, printf, without using numbers of 0. So the easiest way to print the value first element of the array would have been to say numbers of 0. Layman's word, right? Simple. Percentage. Okay, it prints 1. That's the first element. If I do numbers of 1, it would print numbers of 2. It's 2. So this comes up. I don't want to do this. I want to print the first element of the array. Numbers is a pointer, right? How do I find out the value at this pointer? Value at this particular pointer, value at is star, right? Star. Let's go ahead and try that. Star at numbers. It's 1. That's good. Can I do star? I want to find the next element, value of the next element, number plus 1. What happens? It prints 2. One thing to remember is pointers arithmetic works by the size of numbers. So numbers plus 1 does not add 1 to the memory location. If 6000 was the memory location and if I do this plus 1, the answer will not be 6001. The answer would be 6000 plus whatever type you are pointing to. If you're pointing to an integer and the size of the integer is, let's say, 2 bytes, then it would be 6000 plus 2, that's 6002. That would be the next location of that particular array. The same, if you are pointing to a structure, if this is a pointer not to a number but some structure, then if you do pointer plus 1, then it would be pointer plus size of that structure. If the size of that structure is 100, then it would be pointer plus 100. That's one thing which you should always remember. Pointer arithmetic doesn't work directly. If I do a pointer plus 1, it doesn't mean and the pointer is 6000, it doesn't mean it's 6001. It means pointer plus the size of whatever data type that the pointer is pointing to. Here the pointer is pointing to integer. So if I increment this pointer plus 1, then it would be pointer plus the size of int. If I'm pointing to a structure, then it would be pointer plus size of struct. So whatever type you are pointing to, the size of that is incremented. The size of that is added to the pointer. So that's something which you need to remember. Size of pointer. So now I would want to print this element. So I would want to do numbers plus 3. And let's see. Oh, good. Numbers plus 3 is 4. That's very good. So that's how the numbers, that's basically the array, and pointers are related. Instead of numbers, I could have always used pointer, because as we assigned, pointer contains the address of numbers. So pointers plus 3 is 4. How does it work? Pointer, it contains 6000. So pointer plus 3 would be 6000 plus size of int. So 6000, we are assuming int to be 2. So 6000 plus 6, 6006, the value is 4. The 4 is returned back. That's how the internal calculation happens inside when you do any pointer arithmetic. The important thing to remember is when you do any pointer arithmetic, the added value is not the number itself, but the number into size of whatever you are pointing to. So this would be pointer plus 3 means actually pointer plus 3 into size of integer. Effectively, if I do this program here, it would fail, but that's effectively what happens inside your program. So that's basically how arrays and pointers are related. Array is nothing but, the name of the array is nothing but a constant pointer which points to the first location. And whenever we do something like a of 3, actually what happens internally is C converts this into a of, if we write a of 3, then C converts that into star of a plus 3, or star of 3 plus a, one of them. I don't know which one, but C internally converts to this, finds the memory location of that, and returns the value at that particular memory location. And that's also precisely why the first index is 0. So that C can conveniently add 0. That's basically nothing. So it would return the value at A. And that's the reason, I think, one of the reasons why indexing in C starts with 0, because it makes it easy to write the program, the compiler program for that. Okay, that aside, let's move on. What are character pointers, and what is the difference between a character pointer and a character array? Let's move on to that. Unfortunately or fortunately, in C, there isn't a separate data type for string. So any string is actually a sequence of characters in C. So the way a string is internally stored in C is as a sequence of characters. There are three ways you can create a string in C. Three ways I know of. One is using a character pointer. So this character pointer is pointing to a string called dummy. This is number one. The next one is array. I'm creating a character array, normal character array. Most important thing is you should terminate it with a null character. If you want it to be a string, please do terminate it with a null character. So actually, this char array string is a short form of this. So if I want a character array string, I can create something of this kind. C would internally create this array and store it. This particular thing is called a character pointer, and these two examples are character arrays. So this is a character pointer, and this is an array. Usually a character pointer is used to represent a string. So after character pointer, the way things would be stored would be something of this kind. So the character pointer is pointing to some location where D is stored. I'm assuming again the size of character here is 2. It might be, it might not be, depending on the implementation. Dummy, null. So that's basically D-U-M-M-Y, null. So this is how the dummy is stored. When you start printing the value at char pointer, what happens is the C compiler what happens when I try to print the value at char pointer? It would print all the characters until it finds a null. So basically what happens is it starts looping through until it finds a null character. The null character is nothing but the one which we saw. So this is the null character. Until it finds the null character, it continues to print the next character. So the end of the string is when it finds the null character. The main difference between a character pointer and a character array is, I think it's obvious. Character array, it's an array. So the character array is a constant. So char array, I cannot change it. So I cannot say char array is equal to char pointer, because char array is a constant. Even though these two are similar, this will not work. But I could do the reverse. I can make the char pointer to point to char array, because it's just a pointer. It's a variable. I can make it point anywhere I want to make it point. So this runs, but the reverse would not be possible. I think that's the difference between a char pointer and a char array. Other than that, the way it gets passed to a function, the way you can do operations on the content of it, there is no difference between a char pointer and a char array. The only difference is that char array, the reference variable, is a constant, just like any array reference variable, and you cannot modify that. So there you go. I think this video and the sequence of videos before might be a little confusing. Please do go through them once more and see if you have any questions. Good luck with your preparation. Until next video. Hi there. Welcome to this video where we would focus on the wonderful world of pointers. Let's get started. What would be the output of this particular program? Think about it and come back. Welcome back. So, what would be the output of this particular program? For this, you need to understand how the whole thing is stored in memory. Let's run the program and see what the output is first up. So I run the program. I entered a few spaces in between, a few new line characters. So the output is I is 10, pi is star at pi is 10, and some address location is printed. So this is the output. Let's just take this output and put it here for our future reference. So now let's see why the output is this particular thing. To understand this output, you need to understand how pointers work. Let's look at the background. So I have a value int I is equal to 5. So I have a value 5. So I has a value 5 stored somewhere in memory, 6000 let's say, and I have a pointer pi created in here. So I'm saying pi is a pointer, so it might be created somewhere. So pi is a pointer. It has some garbage value initially. So because I didn't initialize anything in here, so the most important thing about the declaration here is int star pi. So the star indicates that it's a pointer. That basically means it is pointing to an address location. So whenever we talk about pointers, pointers don't have values. So pointers will not have values. Here I has a value. What's the value? 5. Pointers will not have values. They would have the address location of other variables. So that's what the pointers would have. So here I'm saying this is a pointer. So the pi is a pointer. So it will have address location of some other variable. What is the type of variable it will have the address location of? That's int. So pi will have an address of an integer variable. So here I is an integer variable. If let's say there were j, k, n number of integer variables, this pi can hold the address of any of them. So when I say int star pi, I'm declaring pi as a pointer. A pointer holds memory location of variables, and here I'm saying it's int, so it contains the memory location of an integer variable. Now in the next line I'm saying pi is equal to address of I. So what I'm saying is take the address of I and put it into pi. So what happens? What's the address of I? Address of I is 6000. So the pi is equal to address of I will make the address of this particular thing stored in here. So that's the most important thing. So now the pi contains an address of the location of where I is. So that's pi is equal to address of I. Address of I is 6000. 6000 is put into pi, and I'm saying star pi. The way you can read these, I mean, it's very important to see how you read these. So when I see anywhere a declaration like this, I would read pi is a pointer to integer. Here I would read it as pi is assigned the value of address of I. So I'll read this as address of I. So address of I makes it easy, and this one I'll read it as value at pi. So what I'm saying is value at pi is equal to 10. So where is pi pointing to? 6000. What is the value at pi? That's 6000. The value at 6000, that's 5. So when I say value at, then it's the value at 6000. So when I say value at a pointer, it's the value at the memory location which is stored as a value in there. So pi, the memory location value which is present in pi, the memory location which pi is pointing to is 6000. So when in this value 6000, I would want to store, what do I want to store? 10. So that's 10. So as you can see, we are changing the value of I as well, because I is also pointing to the same memory location and pi is also pointing to the same memory location. So basically the way it is pi is pointing to the same memory location through the address as the value. I is directly stored at that particular location. So both of these are pointing to the same memory location, and any change that you do to the value of I will also be reflecting to the star pi. And whatever value you do to star pi will also reflect in I. And that's the reason why it prints I10, pi10, and the address location where it's actually stored is something like this. It's not 6000, but it's something of this kind. So this is the actual address location in my computer memory where it's being stored at. So I contains this memory, I is at this memory location, and it has a value 10, and pi is also having this value and it's pointing here. So I hope that's a good introduction to first puzzle on pointers. Let's move on to the next puzzle on pointers. Let's now look at the next puzzle on pointers. This is puzzle 2. So I have done this plus plus star pi. So I'm doing plus plus star pi. What would be the value which would be stored in I star pi and pi? Think about it and come back. Welcome back. So let's run this program and see what the output is. You can see I has a value 6, star pi has a value 6. This is basically the output. The way this expression is evaluated in C is something of this kind. So value at pi, and it's done a plus plus. So the value at pi, we looked at the memory location chart earlier. So we have 5 at I. So when I do star pi, so that's the value here. The value at pi plus plus, this value is incremented 6. And when I print the value, then it prints value 6. So I hope that's a very simple thing about incrementing. You could have done something of this kind as well. Star pi is equal to star pi plus 5. So what would be the output of this? Or let's say 10. Then the output would be 15 because I'm incrementing I and pi by 15. Even if I put something like an I here, it would be the same value. So when I'm changing the value of at pi, I'm also changing the value at I. So that's the next few puzzles on pointers. Let's move on to the next one. This is a very interesting one. So all that I did is I changed this line to pi plus plus. So I'm basically incrementing the pointer. What would happen when I increment a pointer? Think about it and come back. Let's run this program and see what the output is. So it's saying I is 25. Star pi is some garbage. That's interesting. So value at I didn't change. Pi is now value at pi is some garbage, and this is some memory location. If I printed this a little earlier, what would have been the output? Before pi plus plus, let's print the out thing and see what would be the output. So this is the output of this statement. Oops. And this is the output in the second statement. So the value of at pi here was 5, and the value at pi here is garbage. All that I did was pi plus plus. So what happened in the background? Let's try and understand that. So let's change this to 6000 to keep it very simple. So this is 6000, 6000. In this example, we are assuming that the size of integer is 2 bytes. In my memory, it varies from compiler to compiler. And I has a value 5, and pi is pointing to I, and I did pi plus plus. The first thing you need to understand is when I do a pi plus plus, what would happen is the value of this would be incremented by the size of what it's pointing to. So this pi is pointing to an integer, and let's say the size of an integer is 2 bytes. Then what would happen is 6000. When I do a pointer increment, it would be incremented by 2. So it's basically when I do a pointer arithmetic, then you should think as if a pointer is pointing to 6000, if I increment it, it would point it to the next memory location where that type can be stored. So once a value is stored at integer value is stored at 6000, the next one can be stored only at 6002 because the size of an integer is 2 bytes, I'm assuming. So when I increment this pointer, this becomes 6002. And therefore, what is the value at 6000? Because I have not initialized anything there, it would be some garbage value. And that's exactly what is being printed. So the value at pi is now printing some garbage, but the value of I still is 5. So I'm not doing anything with I at all. What I did is I changed the pi to point to the next location, and this location has garbage. So when I print I print a value 5. When I print pi, I print value garbage. So you can see it here as well. So before I do pi plus plus, pi has the address of I, and therefore star pi contains the value of I, which is 5. But once I do pi plus plus, pi would start pointing to the next location. I mean, whatever is the next location after I, we didn't initialize that. So that contains some garbage value, and that's what is printed in here. If you see the difference between these two things, pi values which are being printed, it's 4. So AC, I mean, this is hexadecimal. So AC, when incremented by 4, becomes actually B0. You can try that hexadecimal mathematics. When CA AC plus 4 becomes B0. So the thing what is happening in here is, in my particular implementation, my C compiler, the size of an integer is 4 bytes. So I is at this location. When I do pi plus plus, it's pointing to the next location of the integer. I mean, next location where an integer can be stored. That's this plus the size of integers. This plus size of integer in my implementation is 4. So this plus 4 is what this is. So that's where it's pointing to, and that's what is the location which is printed in here. So I hope that's a clear explanation of what's happening behind the grounds. I would really recommend you to run this program once, try different things, and work them out. This is your next puzzle. And I is equal to 100. What would be the output of this particular program? Welcome back. Here what I'm trying to do is change the address location of I. So I'm saying address of I, make it 100. Is that allowed? Actually, not. This is not really allowed, because you cannot change the address of where something is stored. Where a particular variable stored in memory is something which is decided by the compiler, and you cannot change where a particular where a particular variable is stored in memory. Okay, that's fine. Let's try and change pi is equal to 5. What would be the output? So I'm saying pi is equal to 5. Is this allowed? Think about it and come back. Okay, let's run the program. So you see that the program is running and it's storing a pi value of 5. However, if I try to do a star pi, the output doesn't come up, because the operating system, my operating system which I'm using here is Mac, and it's very protective. So it's not allowing me to see what's the value at 5, because that value is not really assigned to this particular program which is running in here. So the thing is, you can change the memory location and put it to whatever you want, but if your operating system is the result of this operation would depend on what your operating system is. Most of the operating systems these days are protective. I mean, they are secure, and if you are assigning the value of a memory location where you are not allowed to access this particular memory, this particular program is not allowed to access, then you will not be able to see what the value is at that particular location. So that's something which is interesting, because here what I'm saying is I want to see the value at a particular memory location, which I'm saying, let's say xxxxx or something like. I want to see the value at this particular memory location. And when I run the program, here it's not running, because the way my operating system is behaving is it's saying this memory location does not belong to your program. So why are you trying to access it? Something of that kind is happening in the background, and I'm not able to access the value at that particular location. And that makes a lot of sense, because this memory location might be something which is used by some other program and might contain some secure data in there. So you should not allow anybody to access the value in there. But as I said earlier, this thing varies from operating system to operating system, and there might be some old operating systems which might allow you to access the value at that particular location, which would be a security violation because some other program is storing a memory, storing a value somewhere in memory, and this program, this C program which I am running, is able to access that value, and that's a big security violation. But this is how this is one of the reasons why people say C is not really a secure language, because it allows you to access memory locations which will not return from the C program itself. Let's move on to the next program. Okay, what would be the output of this particular program? Think about it and come back. Let's run the program, and I see that the output is 5. Everywhere the value output is 5. So this is quite a simple one actually. Let's just see what's happening in the background. So I has a value 5 and pi is storing the address of I. So that's the first one. Next, I'm saying pj is equal to pi. So pj is also a pointer. So in pj, I'm storing the value of pi, which is 6000. So now when I say I, the value at I is printed. When I state value at pi, so pi is having value 6000, value at 6000 is 5, that's what is printed. Value at pj, star at pj, value at pj, value at pj is 6000, 6000 contains the value 5. So value at pj is 5 as well. So that's what is printed to the output. So everything prints 5. Let's try another program to make sure we understood the pointers well. So I'm creating a variable j having a value 6, and I'm assigning pj is equal to address of j. So I'm saying pj is pointing to address of j, and let's also make pi point to address of I. I'm doing star pi is equal to star pj. What would be the result of this program? What would be the value of I? What would be the value of j? Sorry, I'm not printing the value of j currently. So I'll go ahead and print the value of j as well. So I, j, pi, star pj. So what would be the value which would be printed in there? Let's run this program. So I6, j6, pi. So what happens in the background? So I have a value I, 5. And let's say j is somewhere here and it has a value 6. So j has a value 6, I has a value 5. I'm creating pi pj initially will not have any value, so they would be having garbage. I'm saying pj is equal to address of j. So pj will store address of j, which is 6004. So pj would have 6004 and pi would have the address of I, which is 5. So it's 6000. So p, and I'm saying star pi is equal to star pj. Value at pi is equal to value at pj. Value at pi, that's referring to this memory location. So value at pi is value at 6000, which is 5. So value at pi is equal to value at pj. So value at pj is 6. So what happens is, this is a typical assignment. So value at pj will get copied into value at pi. So value at pj is 6. 6 gets copied into value at pi. Value at pi refers to this memory location. So this becomes 6. And when I print the whole thing out, you see that the values which are printed are I6, J6 and star pi6 and star pj6. So what is happening here is we are creating two, like I and j, both store the value 6. Even though they are pointing to different locations, we have copied the value of I, of j into. So what is the output of this particular program? This is something which we looked earlier in a video in this particular course, but just try and guess what the output of this swap program would be. Welcome back. As we all know, the output would be I6, J6. So this is printing I6 and J6, and Here inside the swap function, which is called next, it's printing A is 6 and B is 5, and here it prints I is 5 and J is 6. So basically the summary is the values of I and J remain 5 and 6. They are not swapped. Even though I'm calling the swap function, they are not swapped. But if I look at the values of A and B, here they were, if I printed the values of A and B here before, then you would see that the values of A and B in the first statement were 5 and 6, and A and B are changed to 6 and 5. So the values of A and B are swapped, but the values changes are not really reflecting back in the main function. So I and J remain 5 and 6. They are not becoming 6 and 5. So they are not getting swapped at all. So what is happening in the background? Let's revise that once again. So what happens is I is having a value at 5 and J is having a value 6. And what we are doing is when we call the function, when we are calling the function swap, what happens is we are copying the value of arguments to the parameters. So somewhere in the memory, there would be two new integer values created with the values 5 and 6. And when we are swapping in the function, what would happen is A becomes 6 and B becomes 5 because of these three lines in there. And once the function gets executed, these values are removed from memory. So this get removed from memory, and when we come back to main, we are still pointing to the old values of I and J. And that's in a nutshell what is happening in this particular program. How do we change that? The way we can change that is by using pointers. Let's write a simple program for that right now. Okay, here we go. So the important change that we have done is instead of passing I, I'm passing the address of I. If I have to store the address of I have to use a pointer. So the swap, I'm declaring A as a pointer to an integer. So this is A is a pointer to integer, this is B is a pointer to integer. And here I'm printing value at A, value at B, and I'm storing in the temp value at A. So value at temp is equal to value at A, value at A is equal to value at B, value at B is equal to temp, and I'm also printing the values at A and B. So basically what we are doing is instead of sending the value of A and B, we are sending the address of I and J. So instead of sending the value at I and J, we are sending the address of I and J to the swap function, and we are trying to change the values at that particular address. And we'll see if this reflects in the output. So this is the output. So as we know, the first statement which is executed is this. So this is the output in here. And next is this. So this is the output from here. The last statement which is executed is this. So this is the output of this particular program. As you can see, the values of I and J are swapped. So I is 6 and J is 5 by the end of the execution. And what happens in the background which causes this to happen? So let's spend some time looking at what is happening in the background with this particular. So I has a value 5, J has a value 6, and to the swap function, I'm not passing I, but I'm passing address of I and address of J. So what would happen is I'm creating two values, A and B, but A and B are not integer variables anymore. They are pointers to integers, so they store memory locations. Which memory location does A store? A stores address of I, because that is what is passed and gets, it's the first one, so it gets here. So address of I is 6000 and address of B is 6004. Sorry, address of J is 6004, and that's what is stored into B, because that's the second thing. Address of J goes to B and address of J is stored into B as 6004. Now, what does the program do? Temp is equal to star A. Value at A is value at 6000, which is 5. So value at A would be stored into temp. So temp would have a value 5. So I will have a value somewhere created temp. This is an integer value, so it stores the value. So temp has a value 5. Star A is equal to star B. So the value at A is equal to value at B. So what happens? Value at B gets copied into the value at A. So value at B, value at 6004, 6. 6 gets copied into value at A. Value at A is value at 6000. So 6000. So the value here becomes 6. Now value at B is equal to temp. So value at B is equal to temp. That means temp value gets copied into value at B. Temp is 5. 5 gets copied where? Into value at B. Value at B is 6004. Value at 6004 is 5. Sure. That's basically swapping the two things. And when I come back into the program, as you would see, the values at I and J have got interchanged and they would get reflected. So I would really recommend you to spend some time looking at this example, try various combinations which are present in here. I think this is a very, very important example to understand. And if once you understand this example fully, then you can definitely say you understand pointers very well. So try and spend some time with this program, try and understand the whole thing, how it's working and all that kind of stuff. And good luck with it. Okay, the next puzzle is on your screen. It's quite an interesting one actually, and try and guess the output of this particular puzzle. Welcome back. Hope this was an interesting puzzle to think about. When I run this program, what's the output? Let's just save please and run it again. So you can see that the values are all 10. So I is 10, star pi is 10, star ppi is 10. Okay, this program shows that actually you can use any number of indirections in pointers. Here the way we read this earlier was int star pi. It means pi is a pointer to integer. When there is a double star, the way you need to read that is ppi is a pointer to integer. Yeah, that's right. ppi is a pointer to integer. So here I'm storing pi is storing address of I, ppi is storing address of pi. So if you look at it, ppi stores the address of pi, which actually has the address of I. So there are two levels of indirections, and that's why here we are saying value at ppi is equal to 10. Sound confusing? Let's see what happens in the background. So I has a value. Oops, let's take all this away. I don't know this. Okay, I has a value 5, and I'm saying pi is storing the address of I. So pi somewhere in memory stores the address of I, which is 6000. Right, 6000 is the address of I, and that's what is stored. And ppi, I'm saying, has the address of pi. Address of pi is 6008. 6008. That's what gets stored in here. So I, pi, and ppi. So I, pi, and ppi. Now you can see the values which are stored in there. So when I said star at star pi, star pi, so it basically means value at pi. So it means star pi, ppi actually means value at and another value at ppi. So first value at ppi. So first value at ppi is 6000. So it's value at 6008, which is 6000. So this is, you can remove this, and it's value at 6000. So value at 6000 is 5. What I want to change is value at 6000. I want to change it to 10. Star ppi, I'm saying 10. So this becomes 10. So in this particular expression, I'm saying I directly points to 10. Pi, value at pi, value at 6000, 10. Star ppi, that's this. So it's again value at PPI. PPI is 6008. So it's value at 6008, which is 6000. So this will be replaced by value at 6000. Value at 6000 is 10. That's the value which is printed. So all of these print the value 10. So that's how this program runs in memory. I hope that's an interesting thing to look at. A couple of words of caution before we end this particular series of puzzles on pointers. The first thing is the size of a pointer. In this particular example, I assume the size of the pointer is 2 bytes. The size of an integer, I'm assuming it as 2 bytes. The size of an integer and the pointer will be dependent on the operating system you're working in. So in your particular thing, an integer might be 4 bytes and the pointer might be 8 bytes. Then these memory locations might look a little different, but however, underlying the things which would happen would still remain the same. Let's see what's the size of an integer and pointer in my particular operating system. So I would print the size. Instead of printing the I print size of I. So as you can see, in my operating system, integer is 4 bytes. Star pi pointer is 8 bytes, and pointer to pointer is also 8 bytes. Again, whatever is the size of pointer to pointer, pointer to pointer to pointer, everything will be of the same thing, because finally they hold a memory location. So the size of a memory, the number of bytes which are used to represent a memory location in my particular operating system is 8 bytes. So that's exactly what would be the size of any pointer, whether it's pointer, pointer to pointer, pointer to pointer to pointer, whatever it is, it would be the same size. And the other thing is, the size of a pointer will not vary with the thing which it's pointing to. So this pointer is pointing to an integer. But if it was pointing to a character, if it was pointing to an array, or if it was pointing to anything else, the size would remain 8. That's because the size of the pointer is the size, the memory, a pointer stores the memory location of something, and the memory location size will not change based on what it contains. The size of a memory location, the size of the address of a memory location will not vary with what it contains. It's a constant. So whatever it contains, the size of the address is the same. So the size of a pointer will be the same irrespective of what value it really contains. So let's end this video on pointers in here. Hope you had a really confusing time with this. Really speaking, try these examples again and you'll be able to successfully understand what's happening behind the scenes. Good luck. Until next time. Bye-bye. And now we would learn what is this operator when related to a structure. What is this related to? Before that, let's discuss how to dynamically allocate memory to a structure. In this program right now, we have created 3 points, 1, 2, 3. But most of the times you don't know how many points there are before you start working on the program. So if I don't know how many points there would be, one thing I can do is create 100. If I need 15, 20, 30, even then I would go ahead and create 100 points so that I can store all of them. This allocates memories for 100 different points, and there is a lot of wastage of memory here. The other way of doing that is by using a pointer and dynamically allocating memory as and when needed. So what I can do is I can have a structure pointer. So this pointer is now a pointer to a structure. And when I have a pointer to a structure, it only allocates the memory to the pointer. It does not allocate memory for the structure itself. The memory for the structure can be allocated dynamically. So now I would want to create some memory where I would want to store this structure in. The way we create memory is by using the malloc function. One of the arguments to the malloc function is how much memory do you want? I want the amount of memory that is equal to the size of this particular structure. So what I'm doing here is I'm saying this is the amount of memory I want, size of this particular structure. So 2 integers, that's basically the size I want, and I would want to typecast it. So I would want to typecast it to a pointer to this structure. So point is a pointer to this structure. So I'm typecasting it to a pointer to this structure, and I'm doing a malloc and doing a size of struct point. So this is basically how you would dynamically allocate memory to a structure. Here I'm allocating memory and I'm typecasting it to a pointer to this structure. So that's basically what is happening in here. So this would allocate memory that is equal to the size of the structure. Now I would want to put some value in here. So I would want to say points dot let's call this point 1. What I would want to do is I would want to say point 1 dot, I would want to be able to say point 1 dot x is equal to 5 and point 1 dot y is equal to 10. So I would want to store a point called 5, 10 into this. But this is okay when the point was a structure in itself. But now point 1 is not a structure, it's pointer to a structure. So if you want to do something of this kind, this is a pointer. So if it's a pointer to a structure, the way we would do that is you need to find the value at this. So we would want to find the value at that particular pointer, star point, and then do dot x on it. So because point 1 is a pointer and not a structure itself, so I would need to do something of this kind. So star point 1 dot y is equal to 5. That's how I would store the value to x. This looks very complex and very tedious, and that's why C gives us a shortcut operator, point 1. When point is a pointer to a structure, you can access the members of that particular structure by using the minus greater than symbol. So this is kind of a shortcut to the earlier thing that you are looking at. So now I can directly set values to the point and access it. Now I would want to print this pointer. Now remember, this point 1 is no longer a structure, but it's a structure pointer. So I have to change the function also. So it's not a structure, but a structure pointer. How do I say that? Is by putting a star before it. Now this becomes a pointer, and this cannot be done because now point 1 is a pointer. So I have to use this operator to print the point. And let's run this program. And now there you go. So in this particular thing, we made a mistake. As we allocated memory, but we did not deallocate that particular memory. This results in something called memory leakage. And how do we deallocate memory? Is by using the free. So free point 1. So it deallocates the memory which was pointed to by point 1 by this particular pointer. And now the program runs, and also in the background the memory would be deallocated. This is one of the problems with C programming, or some people see it as an advantage, some people see it as a problem. However you see it, you have to handle the memory yourself. So you have allocated memory yourself, so you have to make sure that it's deallocated, it's free, and you are responsible for making sure that the particular thing is called.
If you are preparing for C interview, we have a complete C interview guide available. And if you are preparing for a C aptitude test, then we have C puzzles for interview as well. You can find the links to this in the description of this video. If you loved this video, then we are sure you'd love our other courses as well. We have more than 10 GitHub repositories with examples on C, Spring, Java, basic web application, Maven, Mockito. Whenever you are in need for examples, you can look these up. We have a number of courses created on ChalkStreet as well. You can search for in 28 minutes in chalkstreet.com, and there you go. Right now we have 3 different courses in here. I'm sure there will be a lot more courses and we have a lot of courses on C, Java, Spring, and a lot of Java related frameworks and web applications on Udemy as well. You might like some of the most watched videos on our YouTube channel. We have courses on design patterns, web applications, Maven, Spring, Eclipse, and web applications as well. Good luck with your learning. All the best for you. Until next time.